Good day everyone and welcome to this tutorial. In this video, we are going to start editing the UV map, create materials, and textures for this project inside 3ds Max and Photoshop. We are going to focus on the wheel components and its level of detail in this chapter. During the optimization, I have noticed some bad topology in the rim model, first level of detail, that I am currently working on. In the meantime, let's talk about what to expect from watching this video. By the end of this video, you will have a complete understanding of the UV mapping, how to bake maps, and texturing a 3D model. UV mapping is the 3D modeling process of projecting a 3D model's surface to a 2D image for texture mapping. In this process, we are going to use a modifier called the Unwrap UVW modifier. The letters U and V denote the axes of the 2D texture, because X, Y, and Z are already used to denote the axes of the 3D object in model space, while W is used in calculating quaternion rotations, a common operation in computer graphics. These nonsense denotation we are going to explain. However, X, Y, and Z are the commonly used letters in any coordinates system, regardless to what Autodesk denotation are. For convenience reasons, I will use the UVW coordinates letters instead of XYZ. We are going to use the high detailed rim that we have created in the previous video, with 3 iterations in Turbo Smooth modifier options. A very high and smooth detailed 3D object is required specifically to capture a smooth texture, pixel-wise. I am going to project the details of this model with 2 different UV maps in order to create 2 different materials. One for the first level of detail, and the other for the lower levels. If you take a closer look towards the rim pillars, you will notice the unbalanced light and shadows effects as a result of using the default scene lights. This visual variation of the light and the shadows on the rim surface is acceptable in visual effects. However, this rendered image cannot be used as a texture for a rotating part of the game asset, such as the wheel and its components. We need to balance, or equally distribute, the light and its depending shadows effect on the rim surface before baking any maps. Add a standard Omni light to the scene in the front of the wheel at 2 meters distance on the x-axis. When adding a light to the scene, 3ds Max will automatically disable the default lights and only use the added light. After adding the new light, you may notice the slow rendering speed. A simple fix is by switching to the Quicksilver hardware renderer. According to Autodesk, the Quicksilver hardware renderer utilize both the CPU and the GPU computing power while rendering. Let's put that into a good use. Go to the light properties, then lower down the light intensity to 70%. The Omni light has balanced the light and the shadows on the rendered image. That effect will be also applied to all maps we are going to create. Beside capturing or projecting the geometry details, we also need to assign some colors to this rim and its components. Press M on your keyboard to open the material editor. You can switch between different view modes, either the compact or the state. Most of the time, I prefer using the state material editor. It's like having the eagle's eye to see all the scene materials nodes. This is a convenient, user-friendly interface that allows you to access any material is used in the scene in one single viewport without going to other windows to recall them. We are going to use the standard materials for this project, simply because it is compatible with all game engines and other 3D software packages. A proper name of each material is required to ease the identification. You can use a texture of the color you want to use. This might be required for some base color that the game engine will utilize to apply the paint over that texture to ensure proper color features. However, it is inconvenient to connect a texture or an image of a monocolor to the material inside 3ds Max, while you can simply change the diffuse color to whatever color you want. Press Show Shaded Material in Viewport, then assign Material to Selection. Usually, the specular color should be lighter than the diffuse or the base color. You can change the specular color to any color you want. However, the gray gradient is the perfect color range you should pick from. I will keep the specular color for this material at its default white. The specular level can alter intensity and location of the highlights. In the other hand, specular map or color can alter the color of the highlights over the surface. You need to worry about this relationship if you would use a special color for the highlights. We did not change the Omni light color, which is currently white. So, we do not need to worry about any undesirable balancing effect between the light color, the specular color, and the specular level. We are going to use this material for the very high resolution rim and its emblem. And for the bolts, we are going to give them a darker color material. In order to mimic shadows or depth over certain areas in the geometry, such as the bolt holes, we should give that areas a darker color material. However, due to the light and the camera position, rendering a darker color in some areas of the geometry might be too difficult to achieve. We might need to correct that later in Photoshop after rendering the textures. Go to the L0 layer, select the first level of detail, rim, and hide anything else. I am going to project the high resolution rim and emblem of the default layer over the L0 rim. Apply projection modifier over the L0 rim. Press Pick List, then select the default layer rim and emblem. You need to make the default layer and its objects visible to appear on the list. Turn off Display Hidden Objects to narrow the selection. The projection modifier will turn the L0 rim geometry into a cage that capture any objects or details inside. We can push this cage a little bit over the selected objects and even over the L0 rim geometry. I will push the cage by 2 mm. The projection modifier is driven by the UV map of the underlying geometry. 3ds Max by default will generate automatic UV map for any geometry you create. Let's take a look at the current UV map of the L0 rim. Apply Unwrap UVW modifier over the L0 rim object level. We have created this rim from a cylinder primitive, and this is the default UV map look of any cylindrical shape. A part of the rim is still maintaining its cylindrical shape, and the current UV map is actually representing that. However, our interest is in the side part, which carry the required details that we need to capture over the created maps and textures. If we keep this UV map with the current unwrap, the projection modifier will capture only the cylindrical part of the rim, and the resulting maps or textures will not contain the required details of the rim side. We need to manually unwrap the object first and collapse the unwrap modifier to editable poly before applying the projection modifier. The UV map we are going to create is just a template of UV coordinates to drive or guide the projection modifier. We shall need to adjust the final UV map for the L0 rim to make sure that all its geometry are placed on the right texture coordinates. Go to the UVW modifier options and activate selection by element. Select all side polygons of the rim, then project them on a plane on the x-axis. This will flat and unwrap these polygons at the x-axis of the viewport. It's like having a plane in front of the rim, flattened on the x-axis, and this plane function is to capture a UV map from the current selected polygons. Areas, such as a cylindrical part, or any other areas that do not contain details to capture, will be put aside. Any UVs outside the checker box will not rendered by the projection modifier. Let me remind you, this is just a temporary UV map to create textures or maps. The final UV map for this rim will be varied. You can move the UVs on the horizontal or the vertical axis by pressing the locator icon, then entering a numeric value. In either U input, which represent the x-axis, or V input, which represent y-axis. However, W input is meant for procedural maps, according to Autodesk. Currently we are not creating any. By entering 1 in either U or V input, the locator is going to move the selected UVs by one click in relative to the selected UV's location and the selected axis length of the checkerbox or the map. Enter 2 in the V input to move the selected UVs 2 clicks upwards. To move it downwards, enter -2 in the V input. Usually U and V length of the checkerbox or the map are equal, and in our case they are. However, for some maps, they may not. This part is not important for the texturing projection process, so I am going to leave it as it is. The current UV map on your screen will be similar to the one we are going to create for the lower level of detail. However, for the first level of detail, we need the texture to accentuate both the emblem and the pillar's details over the projected texture. We could only project one pillar pair after scaling its UVs over the map, rather than creating a large-scale texture or map to accentuate these repetitive details. Let me show you how to do it. These polygons, or UVs, I just selected, will be used to project the emblem details. Right-click in the UVW editor, then break to detach these UVs. Let's temporarily move these UVs away, somewhere, out of the checker box. You can either select the pillars pair UVs from the viewport, or from the editor, then right-click and break. This part of the rim is the diagonal symmetrical unit that form the rim geometry. Let's break the other pairs and test this theory. Obviously, we need to rotate this highlighted UVs by 72 degrees in clockwise direction to match its couple. There is no option in the editor to input the angle of rotation. This is not the only diminution of function. Notice after breaking the UVs, the origin, or the central pivot, of the original projected UVs is not inherited by the braked ones. And there is no option to align the UV's pivot to the center of the map. Fortunately, identical shapes must have identical central pivot for each. This means we could simply rotate the braked UVs around its central pivot, and having the same result as if they were rotated around their parent origin pivot. And for the rotation angle, we can simply apply the angle snap and change the angle value to 72 degrees. However, having these functions inside the editor would be much appreciated and more convenient. Switch the highlighted selection to Vertex View, then activate the editor Grid Snap. Both UVs are almost identical. Let's snap all parts first and see how closer they are. As expected, the UVs are not 100% identical. There are two solutions for this problem. One of them is by aligning each vertices group horizontally and vertically. During the alignment, you may want to inspect the vertices group selection. Switch to the main viewport and inspect the selection. After completing the alignment, move, and scale one of the pillar's pair UVs to match the checker box. It's better to scale all pillars' UVs together with the emblem UVs for precision and to save our time later when we create the final UV map. Use unified scale while scaling the UVs. Again, all UVs inside the checker box will be utilized by the projection modifier. Other UVs outside the box will not be rendered. The UV map we just created will accentuate both the emblem and the rim details over the projected texture. Collapse the Unwrap UVW modifier. The other solution involved correcting the main cause of this problem, which is the geometry itself. If you watched the previous video, we did follow the diagonal modeling technique to keep all editing symmetrical as much as possible. However, for more precision, I am going to correct the rim geometry by using the radial technique to clone copy one of the pair pillars, which is similar to the radial symmetry, a function currently the symmetry modifier do not have by default. Select one of the rim constructing unit. Detach the selection, then detach the emblem polygons group. Switch to the rotation tool, activate the snap angle tool, make sure the snap angle value is 72 degrees. Make sure that the gizmo is aligned to the center of the world. Hold Shift while rotating the object in clockwise direction. Set the number of copies to 4. There is a plugin called Radial Symmetry that will allow you to achieve the same result. Hold Shift and press Attach to open the attach list, then select all copies. Attach the emblem polygons, then weld all the overlapped vertices. Attach the result back to the rim geometry. Snap or weld the overlapped vertices to fix any gaps. I am going to repeat the previous technique upon the rim bolts. This time, I am going to include the rim bolts inside the UV map. Attach the bolts to the rim, then apply Unwrap UVW modifier. We need to unwrap this old UV map to reflect the changes we made on the geometry. Select all UVs inside the checker box, then apply planar projection on the x-axis. I am going to include some UVs to project them on the x-axis, because the surface of these polygons is almost directed towards the x-axis. The UV map is stored into the 3D object in channels. You can clone or create different UV maps and store them in different channels. When applying the Unwrap UVW modifier, the default channel that appear will be channel 1. You can change it into other channels. However, in this tutorial, we will do all the editing in the default channel. We will not uncover the vertex color channel in this tutorial. Break the UVs in the same manner as before. We know for sure that the checker box, and in relative, this UV map, has equal length and width. But it has unidentified size. During the process of creating this UV map, I used the term unwrapping and projecting. Unless you know exactly the map size, you do not use the term shrink wrap. Time to create the maps, or the textures. Collapse the Unwrap UVW modifier, then apply projection modifier. I am going to give the rim bolts of the default layer, a darker color material. Hold Shift, then left-click, and drag on the existed material to clone it. This rendered image is going to be the texture we capture. And how we capture it will be driven by the UV map we created. Apply projection modifier to the L0 rim, then pick the high-resolution rim, emblem, and bolts from the default layer. Push the cage by 2 mm. Press 0 on your keyboard to open Render to Texture utility. Unfortunately, Quicksilver, Hardware Renderer, and the discontinued NVIDIA, Mental Ray, and iRay Renderer do not support Render to Texture. Switch to Scanline Renderer. Choose the output path, or leave it to default, to avoid any errors with some versions of 3ds Max. The process of creating maps is called baking, and we are here to bake some. From the options, disable the ray mist check. When enabled, it will place a red color over the mist-rendered texture, or empty space. We will do this rendering on the object level by using the existing channel 1. I do recommend to do the render on the object level only. Press Add to add a map into the output table. Currently, we have a complete map in the output table, which will combine all maps in one single texture. It will combine diffuse, normal, specular, and other maps. We will use the complete map as diffuse or base texture. The diffuse map, when rendered, it will be just the diffuse color of the materials that we have assigned to the high-resolution rim and its components. You can change the name, the format of the selected map, and the location to save it. You still can change these properties later after completing the rendering. In order to fix the emblem misrendering, from the Render to Texture utility, pick the emblem object again, then redo the rendering. This time, I am going to add normal and specular maps. The renderer window will show only the complete map. However, the renderer will save other maps to the output folder. Collapse the projection modifier to the mesh. press M. To open the material editor, press Pick Material from Object, also known as the dropper icon. The projection modifier by default will create a material and connect the baked maps to their corresponding slots. In order to view the baked maps, disconnect the original material from the shell material. Then connect the complete map to the diffuse slot of the baked material. You can delete both the shell and the original material. Afterwards, I will save them inside the project folder, then replace the current maps with them. You must keep all files of your project inside the project folder and convert local file paths to relative. In this part, I am going to fix any deformation on the baked textures inside Photoshop. Also, I am going to add a background for each map, since we do not need transparency on the rim textures. For this process, you can use Photoshop or any image editing software. I reconnected the edited maps to their corresponding slots after importing them to the project folder. Now, we need to pack the UVs to match the texture's coordinates. You can optimize UVs by breaking symmetrical parts and overlapping them. Pack the unpacked UVs on empty space over the map or the texture. The process we are working on is called wrapping, and when projecting any UVs is required, the term shrink wrap is used. Since we know exactly the map size we are working on. Further, one of the UV map features is it has a repetitive pattern behavior. This means it can repeat itself outside the map dimension in a pattern-like behavior. However, after baking textures, any disarranged UVs outside the map dimension must be packed or alighted in respective to the texture coordinates. You can freeze selection, then align similar UVs to the frozen. Freezing the UVs will prevent their selection during the alignment. Afterwards, you can unfreeze them. You can render a template for the wrapped UV map to use it as guide for either further textures editing, alignments, or paint jobs. From the Tools menu, select Render UVW Template. I do recommend to keep the template size similar to the texture. Save the template inside the project folder in PNG format or bitmap to preserve transparency. Do not forget to update the template if you change the UV map. Delete the added Omni light to enable the default scene lights. You can increase the specular level of the baked material to enhance the light's effect on the object. Some overlapped UVs may cause some rendering distortion. Moving or relocating these overlapped UVs to an empty space over the map shall fix this problem. Let's bake the maps for the second level of detail and below. This is going to be an easy bake than the previous one. Start unwrapping the side UVs, then pack only those which will be used to guide the projection modifier for render to texture process. Apply projection modifier, then pick the high resolution rim, emblem, and bolts from the default layer. Push the cage by 2 mm. Press 0 on your keyboard to open Render to Texture utility. I am going to follow the same steps as in the previous bake to create the same maps. This time the projected textures will be different because we are using different UV map coordinates to guide the projection modifier. From the Render to Texture utility, pick the rim parts again, then redo the rendering. Press Options, then disable Ray Mischeck. Let's check the rendered texture. We clearly have a distorted texture. Why this is happen? The answer is because we do not have enough geometry to capture the high details, and some areas are not covered by the lower resolution mesh. And if you still paying attention, you will also notice that we did use the default lights during the rendering rather than the directed Omni light. We can fix this by moving the lower level rim to cover the higher level. Or, we could use another approach to save our time. So, we need a surface to capture the high resolution details. At the same time, that surface should cover the high resolution mesh. The question is, do we need more geometry to achieve this? We will find out the right answer in the next chapter.